Hello, it's Fatma Abel, and today I will be explaining the second part of the lecture 2 of renewable energy, which is wind power fundamentals. So first I will start with the fundamental equation of wind power. So wind power depends on volume, which is the amount of air, and velocity, which is speed of air, and density, which is mass of air, flowing through the area of interest flux, which is here. And the kinetic energy definition is the half of the mass times the velocity squared. For the power is kinetic energy per unit time. So if you want to convert the kinetic energy to the power of kinetic energy, it will be equal P equal half m dot, which is the mass flow rate, times the v square. So, and the formula of the mass flow rate, it's density times the area times the velocity. Now I will talk about efficiency in extracting wind power, Betz limit, and power coefficient. Power coefficient Cp is the ratio of the power extracted by the turbine to the total contained in the wind resource, which is Cp equal Pt divided by Pw. Of course, Pt is the power of the turbine, and Pw is the power of the wind. And turbine power output is half times density times area times velocity cubic times Cp. The Betz limit, it's the maximum possible Cp, which is equal to 16/27. And 59% efficiency is the best conventional wind turbine can do in extracting power from the wind. The capacity factor Cp of the wind turbine, the fraction of the year the turbine generator is operating at rated peak power. Capacity factor equals the average output divided by peak output, which is 30%. Capacity factor is based on both the characteristic of the turbine and the set characteristic. Typically, it's 0.3 or above for a good set. The lift and drag forces, and as you can see here, always the lift is perpendicular to the drag, and the principle of working of this force is that a wind turbine turns wind's energy into electricity using the aerodynamic force from the rotor blades, which works like an airplane wing or helicopter rotor blade. And when wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag, and the force of the lift is stronger than the drag, and this causes the rotor to spin. In addition, the rotor connects to the generator either directly or through a shaft and a series of gears that speed up the rotation and allow for a physically smaller generator. This translation of aerodynamic force to the rotation of a generator creates electricity. And I hope that you understand the concept, and thank you.